Well, welcome to this online revision session for AQA FP2. We will be covering the January 2011 question 3 on the topic of roots of polynomials. You should see there are two parts to this question. The first part is just having to show that 1 plus 3i cubed equals 2i minus 2. And then using that result in part B, together with the fact that alpha is 1 plus I, we have this cubic equation, z cubed minus 5 plus I times z squared plus 9 plus 4i times z plus k times 1 plus I equals 0. And then we have various values to find out related to that particular cubic expression. Key thing is the coefficients are not real, they're complex, so the roots do not occur in conjugate pairs. Key thing we do know though is that the sum of the roots equals minus b over a, the pairwise product of the roots is equal to c over a, and the product of all three roots is equal to minus d over a. Alright, these are going to be the key things for this question. Okay, well, first part we've got to show that 1 plus I cubed is equal to 2i minus 2. So key thing will be probably to use Pascal's triangle and expand this. So we know Pascal's triangle goes 1, 3, 3, 1. So the first one will be 1 cubed times that. The second one will be 1 squared times I. The third one will be just 1 times I squared. And the fourth one will become I cubed. And those terms will be added together. So this becomes 1 plus 3i. And then the I squared is minus 1, so this becomes minus 3. And I cubed, well, we know that I squared is minus 1, so this becomes minus I. And so collecting the terms together, we get two lots of I, a 3i minus I, and then 1 minus 3, which gives us minus 2. As required. 2 marks there. One for an attempt at using Pascal's triangle, or a method to determine what 1 plus I cubed is, and then 1 mark for ending up with the correct result. Into part B then, and using that result, as we said, we've got this cubic expression, and we're given one of the roots, and we have to find the value of k, the missing part here. Well, we know that 1 plus I is a root, so therefore it must fit this expression. It must fit the cubic equation. So we know then that 1 plus I cubed minus 5 plus I times 1 plus I squared plus 9 plus 4i times 1 plus I, because that's the value of z that's been substituted in, plus k times 1 plus I equals 0. Well, we've got to simplify this. Well, the first part here, the 1 plus I cubed, we know because we worked that out in the first part, and if we didn't manage to work it out in the first part, we still know it because it's given. We're then going to have to, let's say, square the 1 plus 2i here, so this becomes 5 plus I, and 1 plus I squared, well, it's 1 squared, and then the I squared is minus 1, so the real part disappears and you're just left with 2i. And then if we square out this next part, we're going to get 9. The 4i times the I gives us minus 4. And then we get plus 9i plus 4i. And then we've got k times the 1 plus I. So again, simplifying a bit further, we can see we've got 2i minus 10i, and then that becomes plus 2 there. Remember, in I times I squared is minus 1, but we got a negative in front of the bracket. And then we got plus 5 and a plus 13i. And then we got plus k times the 1 plus I equals 0. We must be getting close now, so if we collect all the coefficients, the constant terms, we've got minus 2, a plus 2 and a 5, so that will give us 5. And then we've got 2i minus 10i plus 13i, which gives us plus 5i. And then we've got k times 1 plus I. And from that we should be able to see that the value of k that makes this 0 must be negative 5. Right, so again, 1 mark for the correct method of substituting in the 1 plus I. Obtaining a correct expansion will give you 1 mark, and then obtaining the correct value of k will give you the 3rd mark on that part of the question. Okay, well, part 2 of this question then asks us to find out what beta plus gamma is equal to. Well, we know, if you remember, that alpha plus beta plus gamma is equal to minus b over a. So that is going to imply, in this case, we know alpha, because that's 1 plus alpha. Sorry, 1 plus I, apologies. Plus beta plus gamma is equal to minus b. Well, b is minus 5 plus I, so this must just be equal to 5 plus I. And so that's the case. Subtracting the 1 plus I from the other side, that gives us that beta plus gamma equals 4. Okay, and there's just 1 mark for showing that result. Then into part 3, that's part 2. Okay, we've got to find the values of beta plus gamma. Well, the only part we now haven't used is the product alpha beta gamma, which we know is equal to minus d over a. So that is going to imply that that must equal, we know that k is minus 5, so we know alpha is 1 plus I times beta times gamma equals minus 5 1 plus I. Remember, k is negative 5. Okay, so that's coming from this piece here with k as -5. So if I divide both sides by the 1 plus I, that is telling me that beta gamma is equal to -5. So with the result from part 2 that beta plus gamma equals 4, I can substitute one part into the other. So you can see here from this piece that gamma equals -5 over beta. So if I substitute that into the beta plus gamma, I will have that beta plus -5 over beta equals 4. We then multiply through by beta. We will have a quadratic, beta squared. Take the 4 across, we get -4 beta minus 5 equals 0. Sorry, I've just realised I made a mistake there, haven't I, with the negative signs, which is often the case. Remember, it was minus d over a, and d over a was -5, 1 plus I, so that means there should have been a +5 in here, which makes that a +5, which makes that a +5, which makes that a +5. So easily done. I always say 90% of your errors are negative signs. Okay, so we now have this quadratic to solve, so we can just quickly apply the quadratic formula, and we know then that beta will equal minus b, so that is going to become 4, plus or minus the square root, well, b squared, so that's 16, minus 4 times a, which is 1, times c, which is 5. Now the coefficients, all over 2a, so that's just 2 times 1, because a is 1. And that will then simplify down to 4 plus or minus the square root of 4, negative, because it's 16 minus 20, all over 2, which will then give you 2 plus or minus, well, the square root of -4 is 2i, divided through by 2 just gives us I. And so we can see that beta is going to be one of those roots, and gamma is the other root. Okay, so marks for that part. Well, there's 5 marks. So for obtaining or using an appropriate method to get the beta plus gamma as being 5, well, it's 1 mark for the method here by using the alpha beta gammas, and then 1 mark for the correct statement. Then again a method mark for then using the result in part 2 and that result for beta gamma to get this quadratic. And then a suitable quadratic then solved will give you 1 mark, and then obtaining the actual roots gives you your final mark. Well, I hope you found that solution helpful. For further help, go to the Further Maths Support Programme website.